All right, we are going to talk about effusion and diffusion of gases. And this hopefully will be brief. Diffusion and effusion. Okay, so first let's talk about diffusion. It's the simplest. So this is just mixing of different gas molecules. So remember we had that problem where we had a vessel that was divided in two, and one side was filled with the gas, and the other side was filled with a different gas. And then we took an eraser and we erased, whoops, oh, we can't breach this side of the vessel. We opened up those vessels. This blue gas is going to go that way. This red gas is going to go this way. And if we look sometime later, what's going to happen is it will be all totally homogeneous. Like what I did with the colors. Blue plus red makes purple. Anyway, the gases will mix completely and completely fill the void. That movement of the red gas from right to left and the blue gas from left to right, that is diffusion. Okay? And this is a large hole, which is not the case with effusion. And so let's talk about effusion. This is escape of a gas molecule through a tiny hole. Okay, so if we have just a vessel, well, let's make it a balloon just for fun. Okay, here's our balloon, and it's filled with our gas. Well, we all know that if we were to kind of zoom in on one little part of that balloon, there'd be tiny little holes in that balloon, okay? And the gas particles can zip right through there. That's effusion. And what happens in a day? You get a little balloon and a sad kid. Okay? So, what do you think can effuse faster? A gas that moves faster or a gas that moves slower? It's pretty simple. Smaller, faster gas particles effuse faster. Now this is why if you blow up a helium balloon, like a helium latex balloon, and a balloon with air, you can try this at home. Latex works best just because those mylar balloons are hard to blow up with air. But you blow them up with one with helium, one with gas, leave them overnight. The helium balloon will shrink much faster than the air balloon. Air is mostly nitrogen, molar mass of 28 grams per mole. Helium has a molar mass of, I think I said 2 in the last video. I meant 4. Whoops. Sorry about that. It doesn't much matter. But it has a much lower molar mass. The particles move faster. They can get through those pores faster. And that's why a helium balloon will shrink, whereas a balloon filled with air will stay much, much longer. Okay, and there's a simple equation to explain this. The rate of diffusion for gas 1, I think I put too many S's in there. For gas 1, divided by the rate of effusion for gas number 2 is equal to the molar mass of gas 2 over gas 1, all under the square root sign. I'm not going to do an example. We don't use this really all that much. But this does actually, it does come into practice sometimes. For instance, we purify nuclear fuel using this method. Used to purify U-235, uranium-235 for nuclear fuel. I'm not going to get into any more detail than that, but there you go.